Okay, so in this video we're going to do an example. It's an application type example. And so it's going to be about the lumberjack logging truck that's delivering materials. And we're just going to read the problem. I'm going to read the problem, then we're going to write down the information. We're going to try to solve or answer the question that they ask. So listen carefully. It says, a lumber truck travels 60 miles from a sawmill to a lumber camp and then back in 7 hours time, travel time. Okay, so here's what's going on. So here's the, let's see, where's it going? Okay, so we've got the sawmill and the lumber camp. Okay, what does it say? It says it travels 60 miles from a sawmill to a lumber camp and then back in 7 hours. Okay, so this distance, 60 miles, and the truck goes there and back in 7 hours. So it goes there and back in 7 hours. Okay, then what does it say? It says, if the truck averages 5 miles per hour less on the return trip than on the trip to the camp. So, because it's empty when it goes to the lumber camp, right? Picks up the raw material and then it travels back to the sawmill. So it makes sense that it would be traveling 5 miles per hour less on the return trip. Okay, so it's the velocity that it's going on there, right? The rate going there is, let's say, x. We don't know what that, oh, let's call it rate. Let's go, so we'll call it rate 1. Because we don't know what the rate is. But we do know the rate coming back, we'll call it rate 2, is 5 miles less than the rate when it was going. So it's going to equal the rate 1 minus 5, right? That makes sense, right? So we don't know what the rates of the truck going there and coming back is, but we do know that the rate coming back is 5 miles less than the rate going there. So if we make this the rate going there, R1, then R2 is going to be R1 minus 5. Okay, so far so good. Now the question is, find its average speed to the camp. Okay. Well, we got a couple things going on. Well, we've got the rate, we've got to the camp, and then we got to the sawmill. And so we know that the distance called D1, and we know the distance, the return distance, D2 are the same, right? We know that the distance there is equal to the distance back, which is equal to 60 miles. We see that from our diagram. We've got rate 1, which we don't know, but rate 2 is equal to rate 1 minus 5. And we also know that the total trip took 7 hours. So we don't know the times, but we do know that T1 plus T2 equals 7 hours. Well, we've got two unknowns, right? We don't know T, we don't know T1 or T2, and we don't know R1 or R2 either, okay? But we want to get this down to one variable. So here's what I'm going to do. Let's use the distance equals rate times time. And let's solve for T. So that means T equals distance over rate. And we can do that for each one of these. So T1 is equal to D1 over R1 plus, and then T2 is D2 over R2, which equals 7 hours. And so now D1 and D2 are both equal to 60, so we can fill those in. These are both the same. Okay. Now, R1 and R2 we don't know, but we can at least rewrite R2 in terms of R1, because R2 is the same is equal to R1 minus 5. And now we've got an equation with one unknown that we can solve for. Okay? Now, so what do? Well, we've got to get rid of the fractions. That's first thing. So again, I'm going to multiply through by the least common divisor, which is going to be R1 times R1 minus 5. So if I do that, right, so I'm going to multiply this whole thing by what? R1 times R1 minus 5. So I'm going to multiply through by this. And that's going to get rid of this and this. So what I'm going to end up getting is this is going to cancel with this. I'm going to leave this. So that's going to give me R1 minus 5 times 60. Plus, now over here, these two are going to cancel. It's going to leave me with R1. And I'm going to have R1 times 60. And that's going to equal what? 7 times this thing. Okay, so we're not done yet. Oh, let me give myself some more room. So let me rewrite this. So this will be okay, so that's what I get. Okay, so now that I got rid of the fractions, now it's just a matter of simplifying this. Okay, so let's simplify this and move everything to the left. Okay, so what do I get? I'm going to get 60R1 minus 300 plus 60R1, which equals 7 times R1 squared minus 35R1. And so now I'm going to move these over. So I'm going to subtract, or no, you know what? It doesn't matter. I'm going to move these over. So I'm going to get a negative 7R1 squared plus 35R1 plus 60R1 plus 60R1 minus 300 equals 0. Okay? So far so good, right? And so now I'm going to add like terms, right? Combine like terms. And let me just make sure I'm doing this. Right, okay, good. So now I get negative 7 r1 squared. And this is going to give me plus 155 r1 minus 300 equals 0. And now what I'm going to do is I'm going to multiply everything by negative 1 just to change the signs. I want this to be positive, okay? So let's just multiply everything by negative 1. So I'm going to get 7r1 minus 155 plus 300 equals 0. And now let's factor this thing. Okay, so again, 7 times 300 is equal to 2100. So we need to find two factors of 2100 that are going to add to 155. Okay? So, what will work? Well, 21 and 100 won't work. So they have to have, again, they have to have both have to be negative because this is negative and this is positive, so they both have to be negative. Okay, so 21 and 100 won't work, so we got to go a little bit higher than that. 41 and, hold on a second, 42 and 50. 42 and 50 won't work. Okay, what else will work? So 21 and 100 won't work. 42 and 50. Oh, hold on a second. 21 and 100. What do we need? What do we need? So that add to 155. Okay, so this is where you just want to multiply. Oh, of course I don't have my calculator with me. Okay, so let's think about this for a second. Okay, so 2100. So 42 and 50. Let's see here. $28 and 75. No, it has to be bigger than 100. So let's see here. No, 150. No, that won't work either. Okay, hold on a second. I got an idea. Okay, so we just gotta find, again, this is the only method, unless you want to guess, or if you want to use the quadratic formula. let's see here. Okay, sorry about that. So if we, what do I do with my markers? Okay, so again, if you have your calculator, you can just trial and error, find out what works. Okay, so 15 and 140 work. Okay, so 15 and 140 will work. You get 1400. 1400 plus 700 is 2100. Okay, so negative 15 and negative 140 add up to the negative 155. Oops, I dropped the R. This should be R sub 1. Okay, so now that means we can decompose the middle term 7R1 minus 140, doesn't matter which way, 140R1 minus 15R1 plus 300 equals 0. And then we can factor by grouping. So I'm going to make this a plus negative. Okay, so this I'm going to factor out a 7R1. Oops, hold on. This should be squared. Sorry, I'm dropping things all over the place. So I'm going to 7R1, and that's going to leave behind an R sub 1 minus 20 plus, and now here I'm going to factor out a 15. Yep, a negative 15. No, yes, negative 15. And then I'm going to get R1 minus 20. Okay, and that's equal to 0. And then now if I factor out the R1 minus 20, now I get my final answer. Well, not my final answer, but R1 minus 20 times 7R1 minus 15 equals 0. Okay, and now this is where I get my answers. Okay, now, so that means by the zero product principle, R1 minus 20 equals 0, or 7R1 minus 15 equals 0. And so this tells me that R1 equals 20, right? Or R1 equals 15/7. Okay, so now, that's what we have. Okay, so now, okay, so let's remember what question they were trying to answer. It says find its average speed to the camp. Okay? Find the average speed to the camp. Okay? Well, R1 was to the camp. So this is the answers for the camp. Now, they both seem like they're good answers because they're both positive, right? Makes sense. This is actually equal to what? 2 1/7 miles per hour. And this is 20 miles per hour. Okay? So they're both positive, right? So everything looks great until you start looking at R2. Because remember, R2 is equal to R1 minus 5. So in this case, R2, the return trip to the sawmill was 15 miles per hour. Over here, R2, you end up with what? A negative answer. So that means this can't be right. So this was the average speed to the camp, 20 miles per hour. And we're done. Take care.